thing I've really been working on, this is sort of my end of the work, is I've been working on this declarative implementation of the protocol. And let me just explain very briefly why I think that's critically important. I actually don't see how you can do a trustless mechanism otherwise. So this declarative statement of what the protocol means, it's at this point it's reduced to about, I don't know, I think there's something like 25, there might be as many as 30 very simple elementary logical statements like if then, or this equals that, or there exists something here, or else this is invalid. So 25 very simple, very clear logical statements that connect ledgers and records and things like that to one another in transactions. And that means you can look at the records and the transactions and the blocks as static data elements and say, this is correct, or this is not correct. They stand on their own. It's not a question of how they were produced. You could have written them in crayon. Doesn't make any difference. Doesn't matter the client that you use to create them. They're just simply right or they're wrong, and that's the end of it. And it's done with these very simple kind of logical statements. Now, it may sound like, who cares? All right, so here's why I think you have to care. One is that as a practical matter, this lets us generate unit tests and code audits of the imperative code, which is what Lun is writing, the actual algorithmic implementation. So the code has to conform to these simple statements, and you hit them with whatever kinds of crazy stuff you want to do in testing. They generate a data item, a block, for example, and then you say, well, is it right? And there's no doubt this is the definition of right, and we can see that we either did it right or wrong. So that's something. It really speeds that kind of code audit and makes it very, very clear and very easy to do. The other is that the second I should say, is this feeds directly into proof of honesty. This is exactly what proof of honesty is. You tell me something, and I don't know where you got it. I don't know who you've been speaking to, or how you arrived at your crazy worldview, but here it is. This is what you tell me. And now I can take it into my corner, and I can have, not me, of course, but my user client say, okay, yeah, I guess that's right, or I guess it's wrong. So that declarative code is what is the foundation of that proof of honesty. And the broader point, I guess, is this, that if you don't have a statement of what a protocol does, then the protocol isn't really anything. A node client, for example, what's written by Ethereum Core, Bitcoin Core, really anybody, that's an imperative implementation. It's an algorithmic implementation. It's just code that does something to data. What does it do to data? Well, it does what it does, and that's the end of it, right? It just does whatever the code tells it to do. It doesn't have any particular relation to a white paper or a technical paper or anything, because no one has ever made a statement of what it is supposed to do. It just does. So if you think that the protocol is doing something wrong, if you think that the miners are doing a fork or somehow violating what you think the spirit of Satoshi is, well, what can you point to say that they're doing something wrong? I mean, in fact, they do things like this all the time. They update the code. They do things that are slightly different. So either it was right before, it was right after. Can't be right both times, right? So that means that it is whatever they say it is. So you simply have to trust that the nodes are doing Satoshi's vision or Vitalik's vision or whoever's vision that you think that you endorse. And
so you're kind of like on the basis of that talking about how like a paper isn't necessarily able to be followed because it's just an algorithmic reaction. It's not actually a protocol with rules and boundaries and like.
It's a sketch. It's a sketch of. That's right. So a technical paper is really a sketch of an intention. Say, here's my intention, now write it in code. And the code is an expression of one particular way to express what somebody believes that intention is. What a declarative statement is this is it logically, and there is nothing else that it can be. If it's not that, it violates the logic. It's a rigid mathematical statement of what it is. As it stands, we just have to trust that the nodes are doing what we want them to do. And my view is that really, trust me, shouldn't be the base layer of a blockchain. If it is, let's just go to the bank.
That's an absolutely phenomenal line, because if you're placing your trust in a node that
Yes,
truly, declaratively told what to do, it's reacting,
that's right.
Almost predetermined until something changes. Whereas if you tell it cannot do this, it will never adapt that. That's the whole, I guess this is where you've gone with the chain of thought of a geek chain instance is that. And if you need to change those rules, you start again.
That's right. So yeah, you don't have to trust me. You can tell me if I'm doing what I said. It's like, it's not Coda's law. It's the contract is actually the statement of truth. You can implement it in Rust or TypeScript or BASIC or anything you like. The code itself is only has to follow exactly the rules that we've laid down. So that means, for example, if we make an error sometime, or somehow there's a library that gets flawed in the node client, it's not a problem, because then the node client wouldn't be following what we say we need, and we can easily update the node client, and that's within protocol. So these concerns about bugs are actually solved by backing it up, not to the code, but to what the code should do.
I'm impressed. You're almost forward thinking and like future proofing. If there's something that needs to adapt, there's you've already thought this is why it needs this might be a case as to why this needs to adapt, or this needs to be amended, and we'll enable that to be done. So, but
we amend our implementation, not our promise to you.
I love that. That's a really amazing line. We've amended that. We need to write that one down. That needs to be a tweet. Yeah, thank you ever so much for your time again, John. It's been a pleasure.
Okay, take care.
Man, take care.
Bye-bye.